Good morning, everyone. So, observer pattern. In the previous lecture, I start talking about patterns, and I make this analogy about patterns being your Lego blocks. You are building a software, you search for solution, you know some solutions that already work, the patterns. And something that we do is try to apply a pattern to solve whatever part of the software can be solved with them. Now, I show you some of the names for the patterns, the gang of 4 patterns, 23 patterns. With the names, the idea is that the name should explain by itself the goal of the pattern, like the one that we review, the observer one. If you remember what we did, the explanation, all this idea of one object having information that other objects need, and the process, well, observing or listening, describe the idea. And behind that idea, there is a class diagram. You want to implement observing. You care about Pac-Man or the ghost information from the other. Controls and visualization. You need to check the controls in order to visualize what the user wants. This is the solution. 4 classes or interfaces connected with inheritance and association. And at the end, when you look into a diagram, a shape like this is an observer function. Someone is observing someone. That is what that part of the diagram is telling us. And the same idea applies with the others. Now, we start working with the observer. I show you this, the diagram. I show you the source code. We review the global idea. What I want to do today is, well, patterns are common, very, very common. And the APIs of different programming languages provide you with the structure to apply the patterns, to use the patterns without the need for create everything from scratch. In this example, subject, observer, abstract classes, interfaces, those are things that you need, but they are not related with the problem that you are solving. In our example, this is Pac-Man, this is the ghost. These 2 classes are something else that we need. Well, these 2 classes, this is something else. They exist in the Java API. So the only thing that you need to do is the classes that are related with your problem, Pac-Man, the ghost, or whatever you are doing here, and you can use these extra classes from the API. In Java in particular, let's talk about that. In Java, if you have a problem, like I am going to move out from the games and something generic, imagine that you have this problem and you have students and you have instructor, professor, tutors. They are 2 objects, and I am going to represent them with these guys. 2 different objects, but in some points in your particular problem, they need to share information, communicate. Maybe the professor is going to ask a question, and maybe the student need to answer the question. The definition is, I have students, I have tutors, instructors, whatever. And this guy is observing, listening. The tutor is expecting information from the other object. With that definition, the student should answer the question from the tutor. If you start with inheritance, composition, association, we can create several different diagrams for this. But if we understand the concept, like, okay, 2 classes, and this one needs to observe this one, the solution already exists. The only thing that we need to do is to apply the pattern with these particular elements. And we need something like this. We have students, a class student. We have professor tutor, a class tutor. Now, we need some place to put the main of the program, the main that is going to create those objects, right? We can put the main in a classroom, just to keep the same idea. But this one is used for the main. And we can use the relationships that we know before. For instance, we are not going to use inheritance between classroom and student or classroom and tutor. We can use having the diamonds, but it's not exactly true that a classroom has like composition or aggregation of these objects. It could be done, attributes, global variables, but let's just use using. The classroom is going to use a student and an instructor for this particular problem. You can imagine that I am going to have the main, and inside of the main, I am going to create variables, and those variables are going to call methods, and that is the relationship using. And in this particular example, the classroom is the one creating the objects and calling the methods. The classroom is the leader, the main. So the arrows point in that direction. Just to be sure that you remember this, because in your exam, this arrow excuse me, pointing in the opposite direction, even though make more sense, the students using the classroom, well, it's not what the code is going to show. Anyway, student and tutor, that is what I need. Now, I need they to observe one to the other. Well, what I need to do is to use the Java API, and in the Java API, you have these two classes. Class number one, you have the class observer or interface. That is the name, observer. And the only thing that you need to do, according with the pattern, and to complete this, is, well, if this guy is a student and I want student observing the professor, I am going to implement the interface observer from the Java API. What I am going to have there? Well, remember, the observer defines the method that is going to be called when something happens. In this case, the observer interface in Java, the name for that method is date. Like action performed in the listeners. For observer, it's going to be used update. Good. Now, student, observer, this class from the Java API, this one, your problem. The other one, the tutor, the element or the class, the object that we want to observe. Well, for that one, in the original pattern, the name is subject. That was the name that the authors of the book use for this class. In Java, we do not use subject as the name for the class. They changed the name. It's the same goal, it's the same functionality, but instead of subject is observable. In Java, you want to implement the pattern observer. What you have is observer and observable instead of observer and subject. The class that is going to be the observer, implement observer. The class that is going to be observed, the subject, is going to inherit from observable. The connection between these two exists, just like in the pattern, but you do not need to show in your class diagram connections between the API classes. You do not show the connections for the labels and the panels and the frames because they are part of the library. The only thing that you show is the connection between your classes and the API or your classes with other of your classes. So this connection, this one, and this one, and I don't care about what we have above, is the API. I use observer, observable, and that's it. This is my class diagram for applying the observer pattern with these two classes. You can imagine that exactly the same you can do with the Pacman, but this is the class Ghost. This is the class Pacman. The Ghost is an observer and the Pacman is an observable. Moreover, if you create childs for the Ghost, if you have the 4 ghosts, the different color with different behavior, if you make observer the parent, all the childs are also observers because you inherit the feature. Now, the class diagram, kind of easy, the source code. Because the goal is from the class diagram, I give you this and you give me the source code, the program running, working. Let's see, source code, 3 classes, observer and observable. Number 1, student, right? A student implements observer. A student is the one that is going to be observed. Implements, because in Java, observer is an interface. Now, observer and observable, you have them in this particular package, Java util. You need to import that. You can just do import Java util asterisk, or your IDE is going to give you those 2 lines because you are only using those 2 from the Java util package. Anyway, it's fine. Now, the only thing that the observer needs to do is to override the method update, provide the method update. Just like when you implement an action listener, you need to provide a method action perform. When you implement observer, you need to provide a method update. The method update, good news, in Java, the method update, just like the listeners, when the method update is called, you receive as a parameter 1 object. The object is the subject, a reference to the subject. In this case, this observable, the object that you are going to receive when update is called is going to be the instructor. So if you are a student and you are observing the instructor, when some information that you need is available, a method update in you is going to be called, and 1 parameter for that method that you are going to have is a reference to the instructor that you are observing. With that, you can use the reference, the object that you receive, and call a method in the instructor. For instance, you're going to be called the update when the instructor asks a question. You're going to be aware that the other object create a question. You're going to be notified with the update, and then you can call a method in the instructor, like asking the instructor, can you repeat the question? And that is the observing relationship. You notice that a question was asked, and then you have the possibility to ask for more details or even ask for the question again, whatever. You have a reference. You can call the methods of the other class. In my example, the only thing that I am doing is I am listening or observing a question, and I am going to print the question. I didn't answer or I didn't follow with things, but you can imagine that here, for instance, if this is a ghost, inside of the update method, your ghost can calculate the next movement according with this observable, be the Pacman, and calling here get X, get Y for the Pacman. So you know the next position of the Pacman, you calculate yours, and then maybe down, you call your own change of movement. You don't repaint to be in a different position. This is the important method, and it's mandatory to put that method there because we are doing this. Any other thing, like this method is my own method. I am calling here my method. Again, you do not want a method that is too long. It's a bad idea to have one method with hundreds of lines. So inside of your class, your update can call another methods, public or private, that are your methods. For instance, the calculation of the movement for the ghost maybe implies several different things to do. You do not put everything in here. Very simple, the student. Now, the tutor. Well, the tutor is going to be the subject. It's going to be the one that have the information that you need. It's going to extend observable. Number one. Number two, you have the information. In Pacman, the information are variables X and Y. For this example, the information are this array of strings, and one of those strings is going to be selected. The information, coordinates, data, strings, arrays, a more complex data structure, is the same. It's just this guy, the observable, is the one that have the information as a global variable. Now, obviously, if you have information as a global variable, well, you can expect to have getters and setters. In particular, the getter is the important one. The getter, this one, is the one that someone else can call in order to get access to the information, right? Now, the getter just provide the information. But one of the methods in the observable, in the tutor, like this one, is the one that update, change, modify that information. In the Pacman, you have methods up, down, left, right. Those are the methods that change the values of the information. Here, I have this method, ask a question. That one is selecting randomly one question from the array and make that one the question that I am asking right now. The method that changes the information in the subject can do whatever the method do, like in the Pacman, but additionally, we need these two instructions. So for the student, implement observer and provide an update method. Two things for the student to do. Two things for the ghost to do. For the Pacman, for the tutor, two things to do. Number one, extend observable. Number two, I'm not asking you for a new method, but in the method that you have, that you modify the information that someone else is interested, add the call to these two methods. And my question for you guys, set change, notify observer, those two methods are where? Because I do not have those methods in this class. What I am doing, and there are no dot before the methods. So those two methods come from, yes, you inherit those methods from observable. What are going to do those methods? Well, if you remember, in particular, the important one is this one. And that one have inside a for loop. And that for loop is going to call the update, like the update in the student, for every single object observing this one. This notify observers is the method that is going to go and say every single object observing me, hey, you did something important. Student, professor, even though the student is the one observing, in programming, what we do is the professor go, and the professor is the one telling student, wake up, you did something important. And the student is going to ask, what was the question? That is the relationship with the pattern. The observable, the subject, is really the one that is going to go and say, I did something with the data. You need to ask me for which is the new data. And that's it. 2 things in the subject, 2 things in the observer. Finally, for the classroom, well, the only reason for the classroom to be is because I need to put the main in some place. Classroom. What I do, and the reason because I have the arrows, I am creating 2 objects. And this is nothing related with the pattern. This is, I am creating 2 objects. And if I create 2 objects with new, but they are local, and this is question for your exam, I am creating a student and I am creating a tutor. They are local. The arrow is this without the diamond, right? If I put these 2 here, global, then we need the diamond. Now, the only thing that I need to do to connect these things with the pattern is tutor, the guide that is observable, add observer. And I am sure that you are familiar with this, like add action listener. Think about what you do with the listeners. Implement the listener and this add whatever listener. And the parameter, in this case, student. With the listeners, usually we do not create 2 classes. We use the same class in which we are as the one that is going to be observing. Tutor, add observer, the student. And you can remember that the only thing that is going to happen here is that the tutor has a list of observers and is going to add this one to the list. And when the notify method is called, every single one object that is here is going to be notified. The update method for this one is going to be called just because you have this record here. The add observer for the tutor, yes, is a method. I am the tutor. I do not have that one. It's a method that I am inheriting. In general, if we go back to the diagram, these methods, this is the subject, the observable, and you can remember this attach is the add observer that I am showing you. The touch is going to be remove observer. Notify is notify observers. It's a little bit longer that I just showed you. And this is the information in your class. And the update, keep the same name, update. So these 2 are the ones that you have in the Java API. And all of this, you inherit here. This one, you need to override here. This one in Java is an interface. This one, keep to be a class. And that is the observer with Java. Small steps that you need to do. Obviously, I mentioned the example with the Pac-Man. I am showing the example with the instructor and the student. Think about other examples. I am going to use others in your exam, in your project. Which are the steps that you need to follow if I give you a class A and a class B, the code, and I ask you to implement observer between A and B or B and A. Another example, if you run this, what you are going to get is something like this with the prints that I put. Basically, the one that is going to be printing this is the student. when receive the question, it's going to print this and the question. Nothing fancy. Now, what if? Yes, the question in the chat, update run automatically. Yes, update is going to be called by someone else, not by you. And that someone else is going to be notify observers. Yes. Just remember the listeners. Something that is very common in programming, and we need to be used to that, is several times I put methods in my source code, like the update or the action perform, that someone is going to call, but I do not know when or how. Is my job is to create that method. Someone is going to call my method, and the only thing that I need to do is to provide the instructions that are going to be executed when that someone call the method. That is the case for the update. That is the case for the action perform in the listeners. No, there is no synchronization because they are not different threads. If we talk about different threads, it's more like producer-consumer thing. Here, what we have is objects, and all of them, they are running in the same thread. And yes, the waiting happened because remember, you are in a for loop, and this for loop is inside of the notify method. And this for loop is calling update. So if you think about the code for this, number one, if you are running this notify method, that is the only one that is running because you do not have concurrency yet. I am not showing here anything related with threads. So this method is running, and that is the only method running. And then if you are running this for loop, the for loop is running, and nothing is going to happen until you go out of the for loop. Now, you call the update one time, and remember, you call the method, you go out, and you need to wait until the call return. And when you return, then you do another loop and call the method, and you need to wait until the method return. And when return, you can do another loop. We are not playing with concurrency, so that is the way. So technically, I am the instructor. I go notify one observer, I did this, and I return. And then I go and notify another observer, I did this, and so on. And that is timing. Good. This is time for calling, time for the get. One of the things that you need to be aware, and I am going to use the question for that, is the patterns. The main goal of the patterns is moreover, solutions that exist. That are the good things, but you are going to notice the cons. And usually when you put some kind of value in the readability, you can be thinking about performance. I am not telling you that the performance of the patterns is bad. That is not the case. I am telling you the performance of the patterns is okay, but you can achieve a better performance with solutions that do not follow the patterns. If your key idea is performance, if you are working with embedded systems or something like that, in which the performance is key, GPU programming also, usually you are not using the patterns. Two things, embedded and even GPU programming, they are sequential, not object-oriented. Patterns are for object-oriented. If you work with objects, those two cases are usually small. For small systems, you do not need the patterns. You care about readability because you have a big system and a lot of people involved. And in those cases, you can sometimes be okay with a little low performance, with sacrificing performance. That is usually the cons with patterns, even if the cons for any object-oriented solution. Object-oriented is slow compared with structural programming. That is something that you already know. The other thing is you have more classes. If you think about a solution for the observing problem between the Pac-Man and the Ghost, I am sure that you can think about several different solutions that do not involve adding more classes. Moreover, do not involve adding interfaces. Use the Pac-Man and the Ghost, and somehow you can connect them and you can achieve the same results. Or maybe you can think about one class in the middle that connect them, so it's only one, not two. But again, any solution that you can think about it is your solution. You use it, you think about it. This one, the patterns, several people have used that solution in several different systems. It's a solution that is proved. So what do you want to do? Research and development, figure out something new that maybe work, maybe not, or use something that already exists. If you are the boss, if it's your company, if you're working alone, any of them is okay. Maybe you can start with something that have already been proved and then move to something else, or maybe you want to work with something else and forget all this. If you're in a company, your manager is going to tell you, use something that already exists. We value your creativity, but this is already proved, and it's about time. You can be 1 week working in something new, or you can implement something that already exists in 24 hours. That is the value with the patterns. Good, okay. Second example. The example that I showed you before, use text. The next one, what if I want the observer, but not alone? So far, my two examples before are examples showing only the pattern. What if I want the pattern, but inside of something like the Pac-Man, a graphical system with panels and things moving and classes that are maybe not related at all with the observing relationship? But let me continue with this example, adding more things. Going back. This one, the association exists because the question in the chat, the association exists. You have, number one, the student is calling a get method in the tutor. So I didn't show you this arrow, but in the source code, this class is calling the get here. Now, second, this connection exists here because it's part of the API. I mentioned this. You do not show in your diagrams the connection between classes in the API because it could be complex, but the connection exists. It's the implementation of the observer pattern, and we have these two lines and these two lines indirectly. So yeah, it's an example of the observer. It's the Java API for using the observer. Good. Next. Okay, question about the exam. I do not remember if I mentioned this, but your exam, the goal for your exam is week 9. So the exam is going to be around October 15, more or less, depending on how fast we finish with the patterns. Patterns is the last topic before the exam. So around October 15, do not remember exactly the date, but I am going to share with you an announcement 2 weeks before the exam. So 2 weeks before, I am going to let you know. Good. So second example with this, I want to make my previous example graphics. I want to add a graphical user interface to my previous example. And the goal is that step number one, we play with the diagram. We can play with the diagram. And playing with the diagram is like, well, if you want to make a graphical application, a graphical user interface for your application, well, number one, the class that you use for the main could be a good idea to add a frame. And you already know that. The connection here, you do not need a pattern. The connection here is use inheritance. The classroom is going to be a frame. It's going to have the main. My application is moving to the graphical user interfaces. Use with that. Now, moreover, maybe, if I want the student that is already implementing Observer, that is part of my previous program, I want to make this guy a graphical element. I want the student somehow to be on the screen, right? I have several options, but the one that I'm going to follow, the easy one, is let's make the student a graphical element. I am going to make a student a child of panel. The student is going to be a panel. The student is going to be one graphical element in the frame. Solution number one. Well, that is kind of weird. You are going to make all students childs of JPanel, so all students are panels. Second approach, I already have Tutor, and Tutor is already observable. Instead of making Tutor a panel, like I did with the student, I want to do another class that is kind of the house of the Tutor. So I have the Tutor, and I have the home for the Tutor. They are going to be connected, and I am going to make the home the one that is a panel. I am showing you two solutions, and I am applying both because I want you to notice the difference. But if you ask me, probably this one makes more sense. The object, the tutor, the student, the person, is not a graphical element, but I can add to a graphical element, like the home, the tutor panel is a panel, a graphical element, and I am going to connect these two, the graphical representation and the brain, the real element. But sometimes what we do, just to save space, is this connection. Anyway, both of them could work. The source code for this diagram. If I show you this diagram, this is basically the blueprint for a program that I want you to do. And theoretically, you know the panels, the frames, and now the observer pattern, and you can implement everything. Let's see. It's another way to have to extend, yes. And you get the idea. The only reason because I select the student to be a graphical element is because the student is implementing this, so can extend this. I cannot do the same with this guy because he's already inheriting here and he cannot inherit from the other, but it's a good pretext to make one and the other. Anyway, this to source code. Your challenge is moving from this to code. You are programmers. You know how to do the programming. Now, I am going to help you, but hopefully it's easy to read. Number one, the student. If I read the code, this is a student. The student is a panel, a graphical element, and the student is an observer. So this class have something related with this thing have a graphical appearance in the screen, and this thing is getting information from some other class. Two things used with the header. Okay, fine. Is something graphic? Well, it's going to have its own variables, have a label. I don't know what is going to happen with that. is a graphical element. So a lot of these things, all the green things are related with being a panel. I can put a color in the background. Oh, I am going to load a picture from a file, a student image. I am going to put that image in a label. I am going to add the label to the panel. Okay, this guy is a panel and it's going to have a label, and the label is going to have something that is a picture, whatever. This and this are the methods that we had before. Answer a question. Is this I am thinking, remember, in the output, nothing new. And this update is the one that is going to receive the observable when I am notified that something happened. I am going to call the method from the tutor, the get, in order to get the question. And well, I am going to call to send that question to this method, so that method can print something, whatever. This is my student. Now, with a graphical representation on the screen. What about the tutor? Well, the tutor is still the same. Extend observable. I cannot make the extend from JPanel. Java do not allow me multiple inheritance, but I have the inheritance from observable. I have the data, and I can change the data whenever I want. The only thing that I need to remember is adding those calls, and I can put that once in one method or in more methods. It doesn't matter how many times I put those instructions. It's just every single method that somehow change the information. Well, you need to notify the people that is observing you that you just change the information. One method or all your methods, it doesn't matter. And you need to provide the getter so the observers can get the information that is supposed to be different to the one that they had before. So far, kind of easy. The graphical part. Well, in the graphical part, the home, and in the home, I need to add the tutor. So I have the panel for the tutor, and according with this, what I have is the panel, the home is going to have a tutor, which makes sense. Like, okay, we can do the opposite. The tutor is the one having the home. In this case, the home is the one that has the tutor. This is the graphical part. The graphical part, the constructor, and I am going to send the tutor as a parameter. So I do not want to do the new here. One thing that I shared with you before is better to have the news in one place, like in the main. Later, we're going to review a factory pattern, but it's not good to have news in every single class. So I am avoiding to do the new for the tutor here. I am sending that tutor as a parameter. The new is going to be in the main. The constructor, all of these graphical elements. Moreover, I am adding this. Is related with observer. No, the tutor is going to be working with listeners. The tutor is going to have an element that is going to be receiving information from the user. With listeners, I am connecting the user with my tutor panel, which is connected with the tutor. And this tutor is being observed by a student. There is a connection here with another class here, with another class here. And this rectangle here is the observer pattern connected with a panel, connected with the final user, with listeners. Putting together Lego blocks in order to create something new. This is the panel, the classroom. Just to finish with the classroom, student, tutor, the connection between them, graphical things, add student to the frame is a panel, remember? And add the tutor panel. And for the tutor panel, I pass as a parameter the object tutor. This put everything together. A frame with two panels, and those panels, one is itself a student, and the other is connected with an object tutor. The main, and make everything visible. And what is the result of this? Well, the result is something like this. A frame with two panels. The panels have inside a label that is used the place for an image. And I add these two elements here with listeners. The listener is for this guy here. And whatever I put here, and I click send, the listener is going to work. It's going to call my action perform method. The action perform method is going to do something, and I am going to notify a student. I'm going to notify the tutor, and whatever I put here in one of the panels is going to be available for the other panel, that in this case is my representation of a student. One object observing another one, which is listening to the user. Communication with patterns. Again, several different solutions. The pattern gives you one that is tested, and if you apply it correctly, your program is going to work. Any question? Okay, guys, see you next lecture. Thank you.